So hello everyone, this is our question. First solve by yourself and then back to the solution. The main purpose for this question is to understand the region of operation of the transistor of Q1 and Q2. Let me mention. The main purpose for this question is to understand the region of operation of the transistor. It seems simple, but sometimes it's tricky for the beginners. So let's begin. First, first we will assume Q1 and Q2 is on, and we have given that VB on voltage for NMOS PNP transistor. Sorry, sorry, okay, not PNP, NPN transistor, and this is our PNP transistor. And the VB on is point 0.7 volt, and the uh, VEB on is also point 0.7 volt. Okay, so if the Q1 and Q2 is on, then this voltage plus minus VB voltage zero point 0.7, and this plus this voltage, if this is on, then this is also zero point 0.7, as this voltage as this transistor is on, so VB is zero point 0.7 volt as mentioned in the question. This is the condition for the forward active region. On means on region. Okay, so this is zero point 0.7 volt, this is zero point 0.7 volt. If we assume this voltage as Vx and this node as Vx and this is V out, then we have two equation for this Vx minus V out voltage, like that if we move by transistor 1, transistor 1 is saying like this Vx minus V out is zero point 0.7 volt. Okay, means the current will flow from this direction to this direction. And if we move by Q2 transistor, then it's this is saying Q2 is saying like V out minus Vx is equals to zero point 0.7, means Vx minus V out equal to minus zero point 0.7 volt. Like this transistor is saying like this voltage moves from current will move from this direction to this direction, but we can say that in this condition, if Q1 and Q2 is on, that uh, for this branch these two voltages not, and these two equation is not exist simultaneously. Okay, means one equation is saying like current is moving in direction, and another equation is saying is this current is moving in this direction. So it is not correct. So this will this condition is not possible for this transistor. Okay, means these two equations not exist simultaneously for same branch. Means one current always one current flow in one direction, not in two direction. Okay, so yeah, now this is case one. This is case one. Now is in case two. Case two. For case two, we are assuming that Q1 is on, and Q2 is off. Okay, let me redraw the circuit. If Q1 is on, we will make like this. If Q1 is on and Q2 is off, and no current will flow from Q2 transistor, so we will not show in the circuit. And this is V out, and a current is sinking from this node, one milliampere node, and this is and this is connected to minus VCC, which is 10 volt. Okay, so this we are not saying this transistor as this Q2 transistor is off, Q2 is off, and this is Q1, which are 10 volt. Okay, so if Q1 is on, this is plus, this is minus zero point 0.7 volt. Now our current will flow in this direction. Okay, This register uh, uh, this register is 1 kilo ohm. We have given that this register is 1 kilo ohm. So 1 kilo ohm register and zero point 0.7 voltage. So zero point 0.7 milliampere current flow in this direction. So if we apply KVL at this node, then so not KVL, so not KVL. If we apply KCL, KCL is saying that the a current will flow in this branch, which is the combination of 1 milliampere and zero point zero 0.07 milliampere, which will give 1.7 milliampere. If we apply the KCL here, as we can see that this is an NPN transistor, and the NPN transistor has a condition, like the condition is the base base current always flows in into the base of the transistor, not out of the transistor, not out of the uh not out of the transistor. Base current always flows into the transistor, and this is our supply, which is 10 volt. This is IC current, and this is IE current. Then always the transistor equation is satisfied, which is I I IE is the combination of IC plus IB. Okay. If the base current is flowing in this direction, then it will become IE IC minus IB, which is not correct. So this possibility is also not correct. So Q1 on and Q2 is off is also is not correct, which will not give the Vout solution, Vout voltage. Okay, so we will consider this case as well, as base current is flowing out of the NPN transistor. Remember, it is NPN transistor. So NPN transistor, no base current flows outside of the transistor. Always the base current flows inside of the transistor. Okay. Now, if we consider case three, in case three, we will assume Q1 is on. This is Q1, uh, Q1 on, and Q2. Sorry, Q1 off and Q2 on. Okay, now let me read out the circuit. If we assume the Q1 or Q1 off, so no current will flow in Q1, no current will flow into the Q1. Q1 is off, so we can remove this Q2. So this is resistor, which is 1 kilo ohm, and this is NPN transistor. Sorry, PNP transistor. This is PNP transistor, and sorry, it's not like this. Okay, let me draw again. This is the circuit. No, this Q1 is off. So if Q1 is off, we can draw the Q2. Let me redraw the Q2. This is resistor, and this is PNP transistor, and it is connected like this. Okay, and voltage, constant voltage pulling this current. Sorry, and this node is connected to the minus VCC. And this is resistor. This is 1 kilo ohm. This is also 1 kilo ohm. No, it's not 1 kilo ohm. This is 1 kilo ohm. This resistor is 1 kilo ohm. This is V out, and our resistor is connected to this 1 kilo ohm. And this is PNP transistor. And now for this, and the Q1 is off, so we will not show the Q1. This is Q2. Now this voltage is 0.7 volt, which is like this, and in this we can say the current flow in this direction. Okay, current will flow in this direction, which is uh, which is uh, 0.7 milliampere. Now which is 0.7 milliampere. Now we can apply a KCL at this node. At this KCL, 1 milliampere current is going. 1 milliampere current is going flowing this branch, and another zero point 0.7 milliampere is flowing in this branch. To now, if we find this base current is the base current is this is the input current plus zero point 0.7 milliampere, which is the outgoing current, which is 1 milliampere. So the base current is 0.3 milliampere, we can say. And at this time the direction of the current is correct, as NPN current direction is base current direction is this, and this is emitter, this is collector. So collector current direction is this, emitter current direction is this. Okay, so the base current flows in this direction. Okay, now this is now this is sorry now uh, this this direction of the current is correct, and the current is zero point 0.3 milliampere, and we know the property for the this is our emitter current is this is our emitter current, this is our collector current, and we know the relationship between the collector current and the base current. The collector current is the beta times of the base current, and the emitter current is the combination of collector plus current and base current. And the collector current is beta IB, and this is base current, which gives beta plus 1 IB, and beta is 20. We have given the beta. Where is the beta? Beta is 20. Beta is 20. So so this is 21 into IB is zero point 0.3 milliampere. If we calculate this, let me calculate. If we calculate this, we will get 21 multiplied 0 0.3, 6.3 milliampere. 6.3 milliampere. This is emitter current. So the emitter current in this direction is flowing is 6.3 milliampere. Now we can say at this node, if we apply KCL at this node, at this node, 0.7 milliampere current in this flowing in this direction, and 6.3 milliampere current flowing in this direction, and the combination of this current flowing in this direction. Okay, so if we denote this I is 6.3 plus 0.7, which gives 7 milliampere current, and negative of this current, this I current flow from this branch, and a voltage drop will create, which is 7 volt. So we can say V out is 1 kilo ohm multiply by 1 kilo ohm multiply by minus 7 milliampere current, which will give V out is minus 7 volt. So this is our final solution. Hope you like it.